What is a Docker container and how does it work with images? Imagine being able to run your application anywhere without worrying about the environment. That's what a Docker container makes possible. It's like a mini, self-contained computer that runs your software smoothly wherever you put it. A Docker container is a lightweight, standalone package of software that includes everything needed to run an application. This means it has the code, the runtime environment, system tools, libraries, and settings all bundled together. Because of this, containers run consistently whether on a developer's laptop, a cloud server, or a physical machine. Containers work in isolation from each other and from the host system. They use features built into the Linux kernel, such as namespaces and control groups. These features let multiple containers share the same operating system kernel but keep their environments separate. This setup makes containers efficient and fast, with less overhead than traditional virtual machines. Now let's talk about images. A Docker image is like a blueprint or a snapshot of a container. It's a read-only template that contains instructions for building a container. Images are made up of layers, each layer adding or changing files and settings. Think of it as stacking building blocks that define the application and its dependencies. When you want to run an application, Docker uses an image to create a container. This process is called building a container from an image. Docker first checks if the image is available locally. If it isn't, Docker pulls it from a registry like Docker Hub or a private registry. Once the image is ready, Docker creates a container by adding a writable layer on top of the image. This writable layer allows the container to change files or settings during runtime without altering the original image. This relationship between images and containers is key. You can think of images as the starting point, the recipe for your application. When you run an image, Docker makes a container that runs your app in an isolated environment. The container is like a running instance of that recipe, with its own file system, network, and process space. In cloud environments, Docker containers are very popular. Major cloud providers like Amazon Web Services, Microsoft Azure, and Google Cloud support running Docker containers directly. You can deploy containers on managed services like Amazon Elastic Container Service, Azure Container Instances, or Google Kubernetes Engine. This makes it easy to develop locally and then deploy the same container to the cloud, ensuring consistency and reducing deployment issues. In DevOps workflows, Docker images are built automatically as part of continuous integration and continuous delivery pipelines. When developers push code, the system builds a new image, runs tests inside a container based on that image, and then pushes the image to a registry. Deployment tools then pull the latest image and start containers across different cloud environments. This process makes deploying updates faster, more reliable, and easier to manage. Security is also important. Best practices include scanning images for vulnerabilities before deployment, using minimal base images to reduce attack surfaces, and applying the principle of least privilege for container permissions. Cloud providers offer tools like Amazon Elastic Container Registry Image Scanning, Azure Security Center, and Google Cloud's Container Analysis to help with these tasks. In summary, Docker containers are like portable, self-sufficient units that run applications consistently across environments. Images serve as the blueprints that define those containers. This setup makes modern cloud infrastructure more flexible, reliable, and easier to manage. By building and deploying Docker images, teams can streamline workflows and ensure their applications run smoothly no matter where they are hosted.